Welcome to our oral presentation, where we will discuss the Google Merchandise Store Customer Revenue Prediction Project. This presentation has been prepared by 61 Data for Donald Wedding, the CEO of Robertson Marketing. The following topics will be covered during our presentation, which include an introduction to the team, an overview of the project, our approach to the project, exploratory data analysis, customer segmentation, model development, the project outcome, demos of our interactive dashboards and mobile application, next steps, and the final project delivery. Before we begin, I'd like to introduce our 61 Data project team members who have performed the work and will be presenting today. First up is Pauline Chan, who was our data visualization specialist and technical writer. Next is Sheila Nesselbush, who was our lead data modeler and technical writer. Following is Bruce Pham, who is our project manager, data modeler, and mobile app specialist. Next is Francisco Roche, who is our data modeler and technical writer. And finally, myself, Robert Schell, serving as lead technical writer and storyteller. The next few slides will discuss an overview of the project with an introduction to the opportunity, our problem statement, and the objectives of the project. Google is an American multinational technology company that specializes in internet-related services and products. Google operates an e-commerce online store that sells Google's branded merchandise, called the G-Store. The G-Store is managed by Robertson Marketing, who has engaged 61 Data to honor Google's ongoing initiative to find better and smarter ways to work in order to bring innovation into the G-Store branded merchandise marketing space. The G-Store is experiencing the Pareto phenomenon, where 80% of the revenue is generated by 20% of the customers. Furthermore, only about 1.27% of online traffic sessions result in a transaction. Due to this, it is difficult for Robertson Marketing to predict customer revenue or to effectively target the right customers. Our team is engaged to develop machine learning models for G-Store's customer revenue prediction in order to boost customer acquisition and retention. Using the G-Store user traffic data from August of 2016 to August of 2017, our project objectives are to be able to classify user sessions as transaction likely or not, predict revenue generated by each customer, provide insights from our analysis, suggest possible operational changes that can benefit the G-Store, and suggest better ways to use the marketing budget. Our project approach was to gain thorough understanding of the data through exploratory data analysis, then begin to specify models for parameter estimation and adequacy checks. Adequate models were then fed forward to our model validation stage, and a final champion model was selected by demonstrating the most accurate classifications and predictions. The data for our project was provided by Kaggle for the Google Analytics Customer Revenue Prediction Competition. This data described online user traffic at the G-Store. There were two datasets provided. The training data consisted of approximately 900,000 observations from August 2016 to August 2017, and the test data consisted of approximately 800,000 observations from August 2017 to April 2018. Each dataset was comprised of 12 data fields, and many of the data fields were JSON blobs that needed to be flattened to be separated into their own columns. After flattening, the training data had 55 variables and the test data had 53 variables. The test data had all the same variables as the training data, except for the transaction revenue response variable and a particular campaign code variable. Next, Francisco will discuss our EDA process and customer segmentation.
Thank you, Robert. Well, now this section is about the EDA and the segmentation process after we go into the modeling with Sheila. Now we see that the response variable, the transaction revenue, it's a zero inflated, very highly zero inflated response. It's very skewed, as we see in the graph in the top left. When we separate and only take the revenue and we do the log, we can see that it's a very well curved belt in the transaction revenue, and you can see it in the right side of the of the slide. Then we go to the predictor variables. We have 16 category variables, 2 dates variables, binary, integer, and mostly the majority are strings or categorical variables. So it's a very heavy data, not numeric form of data. We have a lot of missing values and with the data, as we can see in red in the on the right side on the graph, and then in orange between 15 and 90% as category as bad, and between 5 and 25% is okay, and you can see in red. So we discard the variables that are very bad or remove classification. Next, we analyze a little bit, deep analyze the data, and we found some inconsistencies between country, region, and city. As we can see, for example, in the section in Brazil that I highlighted right now, we can see country Brazil, region California, and city Los Angeles. And we can see other examples with Brazil, Canada, Chile, and China, and so on. So there's some couples of mismatching between country and region, although this mismatching is not representative of the data. Is below 1% of the data set. So we don't consider this a big roadblock for the analysis. Moreover, we on more suspicious data, we found some discrepancy between bounds and page view, where the bounds are 0 when a single page view is and vice versa, and we see all duplicate sessions. The number of records on the session is 898, and the records are 17,600. So as we can see, 1,796. Sorry, and we see here is not as we see it's very consistent. The data we have some issues, minor. Consider the size of the total data. When we move a little bit along with the transaction revenue, our dependent variable, that we see that the hits and page view have a high correlation between both, and other has some important correlations, but not as strong as hits and page view with the transaction revenue. Now, the next where I'm going to talk about customer segmentation. First, we try to do a recency frequency monetary value, or what is known as RFM, but since the transaction revenue was a highly skewed and self-inflated pattern, the RFM model was very poor and with extremes, so it was not distributed in equitative or in a good way to use the RFM. It was very skewed. So we try other methodologies to segment. We try k-means, and we did a grid search to find out the best cluster. Although, as we can observe in the foregraph, we found out that k-means always have groups very small compared to others, and for segmentation this is not a very good, because that means it's not a good methodology, since we have a very small groups within K-means pattern. So we discard K-means methodology and not try to use it for segmentation. We also try other segmentation like PAM or hierarchy, but since the database was too big and we have some limitations in hardware. The other that we could run was the model-based clustering. On the right side, we did a best selection on BIC and number of components or clusters, and at glance looks like the 12 is the way to go because that's the BIC. However, 12 segments are too many and difficult to handle at the beginning. So our approach will be the proposal is to use first a 6 cluster segmentation, and then with time we can move forward to 12. So if we go to as we can see in the circles, if we go to the results, we see that we have clear 6 segments and how these segments are differentiate between them and the number of total sessions. As we can see a difference with the K-means. Almost all the 6 clusters have a good quantity of sessions to be segmented. So we found one, we call it US heavy users, only USA enthusiastic users. We found one what we call in the middle because it didn't stand out with everything. It's like an average in every single variable that we can spot on. Then we have early month, some customers that only go in the early days of the month. That's so if we can target those customers at the beginning of the month. Then we have some customers are campaign prone that are very subject to AdWords or any campaign that Google may try. They click on those campaigns, so they are very open to or sensitive to any campaign that Google may look. And then we have some customers that are more geographically distributed around Asia region. Lastly, we go to the data transformation. Since the response variables is a very skewed, we did the log of the transaction revenue. We standardized the data set compared to zero mean and univariate variance, and in the within categorical values that we see at the beginning that we have a bunch of an important number of categorical values. We factorize with domain coding, ranking technique, and binding to handle this data transformation to go to the modeling piece. Lastly, before I go to the modeling, we split the data between 25 and 75 for training and validation in sample model development and auto sample assessment. And now we are going to talk about the models, and I pass to Sheila. Thank you.
The next model tested was a light gradient boosting model. Again, a light GBM model was fit using all of the data, and the results will be included in the table on later slides, but for now we'll only discuss the 2-part model. Light GBM works similarly to random forest. However, rather than splitting on levels, the light GBM splits the model on individual leaves. First, a light GBM classifier was fit. However, it performs slightly different than standard classifiers. Rather than predicting a binary variable to determine if a transaction occurs, this model predicts the probability that a transaction occurs. Then, these probabilities are converted to a 1, indicating a positive transaction, or 0, using various cutoff values. A low cutoff value of 0.03 provided great results and the best classifier fit yet. This low value is due to the fact that less than 2% of the training data shows positive transactions. The top predictors in this model are page views, city of transaction, hour transaction occurred, and visit number. Next, the light GBM regressor was fit. Again, only the rows with positive transaction data were used to fit the model. This model indicates that the top predictor variables include page views, visit number, hour when transaction occurs, and city in which the transaction occurs. It's interesting to note that these are the same 4 variables as the classifier. Both the classifier and the regressor perform better than any model fit thus far. The same process was used for this light GBM classifier as the one just described. However, the only difference was that the data was upsampled to increase the number of positive classes to evaluate whether this could improve classification. Since upsampling was important for improving the classifier, only a classifier was fit. To perform upsampling, random samples are drawn from the minority class, which in this case consists of positive transactions, and added to the dataset until the number of entries in the minority class is equal to the number of entries in the majority class. In other words, until number of rows with positive transactions is equal to the number of rows in which no transaction occurred. Again, this classifier performed very well. It's interesting to note that the cutoff value is 0.5 rather than 0.03 due to the change in data. Despite slight improvement, the light GBM classifier with the original data is preferred because the improvement with upsample data was not enough to risk the bias that may occur. Once all the models were fit, it became necessary to evaluate performance metrics and select a champion model to recommend to the company. To compare models, we focused on area under the ROC curve for classifiers and root mean squared error for any regressors. Based on these results, we chose the light GBM classifier as well as the light GBM regressor with the original data. This classifier did not have the highest AUC, however, as previously mentioned, it was only slightly lower than the classifier fit with upsampled data, and it avoids potential bias. For the regressor, this model had the lowest RMSE value, indicating best performance. As explained, the champion model selected was light GBM classifier with the light GBM regressor, using original data. The classifier has an AUC value of 0.958, which means that greater than 95% of the validation dataset was correctly predicted. The regressor has an RMSE of 1.092, the best of all regressors tested. In addition, the model is easy to use and clearly indicates the most influential variables, allowing management to define clear goals in terms of improving these variables. Both the classifier and regressor had the same top variables, which include page views, city, hour, and visit number. I will now pass it over to Pauline, who will discuss the interactive dashboard.
So Tableau was used in this project to create data visualizations and interactive dashboard. While R and Python can create robust graphs, business audiences usually appreciate interactive visuals that are easy to use and view. Being an industry leader in data visualization, Tableau is ideal for our project's use. It is easy to use. It has drag and drop interface that promotes faster time to market delivery. With access to different types of visualizations, our team was able to perform quick EDAs and investigate on missing and suspicious data. With instant geocoding capabilities, Tableau automatically converts our local data into rich interactive maps, allowing our team to visually identify and explore the data. Users can interact with the data through dashboard filters and drill downs. Dashboard filters allow users to choose their desired views of data, while drill downs allow users to navigate to a different layer of data granularity by clicking on a data element in the visualization. The created visualizations were easily uploaded to Tableau Public for effective team collaboration. Lastly, Tableau is mobile and device friendly. Visualizations can be generated on different types of mobile devices and on different sizes of desktop screens. With this layout flexibility, the team will not need to build a specific mobile phone app. For this project, a set of 3 dashboards were created to convey findings and KPIs using the static data provided from August 1st, 2016 to August 1st, 2017. The dashboards created are accessible on Tableau Public through the following link. Clicking on the link provided in the previous slide will bring you to the set of Google Store dashboards in Tableau Public. Users can switch between the dashboard by selecting the tabs at the top left-hand corner of the web page. Three dashboards were created: the GStore Overview, which provides an overview of the transaction revenue, visitor conversion rate, and session conversion rate by the key predictive variables. The Other Observation dashboard provides details on EDA findings, and the Suspicious Data dashboard provides details on the suspicious data observed. What you see here is the GStore Overview dashboard. So 3 dashboard pages were created under the GStore Overview dashboard. So we have the Revenue Overview dashboard, Revenue by Visitor, and Session Overview. In each of these dashboards, interactive heat maps were created so that users can identify and focus on the selected details when needed. The Revenue Overview dashboard provides an overview on the transaction revenue from GStore. In this dashboard page, user can choose the desired data by clicking on a country in the interactive map. For example, they can click on the US, and the rest of the dashboard will filter on United States, giving you the detailed results on United States only. Or they can also click on a particular month in the month chart, in the bar chart. And as you can see, clicking on December will show you details. The rest of the dashboard will show you details on December only. So let's reset this. Filtering can also be done by updating the dashboard filters on the right-hand side. So the revenue flag, user can select whether they want to present all revenue, or transactions with only revenue only, or like no revenue. And they can select a certain range of transaction revenue, and also the continent and the visit month. As observed here in this dashboard page, the highest overall revenue comes from United States. It also comes from the referral channel, and also December. The Revenue by Visitor dashboard page provides details on GStore's revenue by visitor. Here you will see the visitor conversion rate, the transaction per visitor, the revenue per visitor, and also the most valuable visitor by country, by channel, by medium, is mobile and OS, and the day of week. The conversion rate is an important metric for measuring online transaction performance. Since more traffic, i.e. more sessions, does not necessarily mean more sales. So the conversion rate is used to measure if the traffic generates good sales. And this KPI is broadly used to optimize business ROI and profits. The visitor conversion rate here provides the information on how many visitors become buyers, and is derived by dividing the visitor with revenue by the total of visitors. Users in this dashboard page can choose to look at more granular data by clicking on a country, on a particular country in the interactive map. Filtering can also be done by clicking on the dashboard prompts on the right-hand side. As shown in this dashboard page, the visitor conversion rate is at 1.4%. Average number of transactions per visitor is at 3.6, and average revenue per visitor is at $154. Most valuable visitor is determined by averaging the revenue with the number of visitors in each group, for example, country. And here, in this example, Nigeria is found to be the most valuable visitor with $3,000 per transaction. The Session Overview dashboard page provides an overview of the number of sessions and the top countries by session conversion rate. The session conversion rate provides information on how many sessions generated revenue, and is derived by dividing the number of sessions with revenue by the total number of sessions. Here we can see the session conversion rate is at 1.28%, meaning that from all the visits to the GStore website, only 1.28% of the visits generated revenue. The other observation dashboard contains details mainly for EDA purposes and to showcase the EDA findings. So we have for example, we have the new visits and Is-True-Direct, which provides details on the negative correlation found between the two predictive variables. Then we have the visit start date. This dashboard page shows that December is the highest revenue generating month, and less sessions and revenue is observed on the weekends. As for page views, A page view is each time a visitor visits a page on GStore. So we can see in here that the revenue distribution of page view is highly right skewed. And it also shows that most revenue over here comes from smaller number of sessions. Whereas you can see, this small page views, like page views under 8, generates almost no revenue. And then we also have the revenue dashboard page that shows the log of transaction revenue. We also have channel and browser, which shows the high revenue channel groups and also browser groups. It's basically the same for device category and as mobile. So it shows that desktop, non-mobile desktop, and also desktops are the higher generating revenue categories. And also we have the operating systems showing that Macintosh, the Mac has the highest revenue, but the Windows have the most sessions of it. So let's go into suspicious data. This dashboard was created to analyze suspicious data as identified from the EDA process, and also can be used for later data verification. We have the country, region, and city dashboard page. This dashboard page shows the details on regions and cities that were slotted to the wrong country. So for example, we see that California is, and like with the city of San Francisco, is slotted to Argentina. On the other hand, like you see all these cities and regions slotted to the wrong country. Then we have the duplicate sessions. This dashboard page shows all the information on the duplicate sessions observed. So we can see that around like 897 sessions were duplicates. So we want to figure out what caused the duplication, and we figured out that these duplications seems to be caused by sessions that are logged that bridge across 2 days, two consecutive days. So 2 sessions were created. For these duplicate sessions, for these 2 duplicate sessions, we probably have to clean the data and merge these 2 data into one. Lastly, we have the bounce and page views. Bounce is the same as a session with a single page view. And analysis is performed to ensure that this principle is conformed. And here we can see that we have around 450,000 records that conform to this rule, but we have around like 2,000 records that do not conform, where the page view is 1, but they were not bounced. So data treatment will probably have to be done to fix these data. So next, Bruce will discuss mobile app and project next steps.
From our champion model, the top 2 predictors are total page views and visit numbers, which Network Solutions has defined page view as the measure of how many times someone has viewed an entire page, including all text, image, etc., and visits as a series of hits from any particular IP address. According to our model, to increase purchasing rate percentage, the e-commerce site and mobile app should motivate or encourage users to visit the site more often, and that he or she views more pages while visiting. One way to incentivize our customers to return to the e-commerce site is to offer special discounts for returning customers. Next, I will demo a prototype of our next mobile application. Note that the mobile application has not identified the user. I will sign in as John. After logging in, the mobile app has identified the user as John. Because John is a returning customer, he is automatically offered $10 discount on all shirts. As John clicks on the links to the different shirts, the the mobile application captured the page views, web pages, JAWS views. At the bottom of the mobile app, notice that the mobile app has provided featured products based on a recommendation model to increase revenue per transaction by cross-selling to returning customers. The next few slides will cover recommendation and future works. Our team has a 4-part recommendation. The first recommendation is to launch a 2-part light GBM classification and regression model. This will enable effective monitoring, functions to validate the models on new and out-of-sample data, assist in identifying areas of potential future refinement. Our second recommendation is to develop an acquisition and retention strategy to target the identified 6 customer clusters from the segmentation analysis. Our third recommendation is to connect the Tableau dashboard to the live GStore data. Doing so, this will provide self-service BI functionality to the GStore marketing and business team. Lastly, we recommend to complete the deployment of the mobile app prototype. This will support and increase sales in conjunction with the acquisition and retention strategy developed based on customer segmentation analysis. Future work. First, set up monitoring period to evaluate the implemented champion model. Second, identify areas for model maintenance and refinement. Third, understand potential causes and mitigation for possible drift. Fourth, develop customer targeting initiative and enable tracking for efficacy. Fifth, connect Tableau dashboard created to live GStore data. Fifth and final, continue deployment of mobile app. To conclude, the project had 4 key deliverables: the project goals, initial finding report, the final report and executive summary, and lastly, the oral presentation. From the onstart, 61 Data came together to work as one team. The project and deliverables were well understood by the team, and each member understood his and her role and contribution to meet the deadlines. 61 Data followed the project schedule and met deadlines as scheduled. Lastly, I want to thank the 61 Data team for making the final course in the master's program a fun and learning experience.